Yeah, good evening everyone. Good evening. Am I audible? Am I audible? Am I audible? Check once. Am I audible? Please verify audio video okay or not. Yeah, fine. Let's go to the class. So yeah, in the previous classes we seen all these things. In the previous classes we seen all these problems. Right? This problem also done. Yeah. Right. Problem number 128. So we are going to discuss in the RIC, in the Algo RIC, we are going to discuss 300 problems minimum. 300 problems, very good problems. 300 we are going to solve in the right algorithm RIC. In the last few classes we done few, right? Now in today's class we are going to solve few more. Can you see what is the answer of this problem? Can you try this? Can you try this? What is the answer of this problem? Two matrices M1 and M2 are to be stored in arrays A and B respectively. Each array can be stored either in row major or column major order in contiguous memory locations. The time complexity of an algorithm to compute M1 and M2 will be. Yeah, this is a given problem. Right? So what is the answer you are thinking? Can you go ahead? Try. If anyone knows. It's one of the tricky problem. Let's see how many people will give answer. It's one of the tricky problem. Anyone? Check once. Anyone can give answer for this? There are two matrices. You want to multiply both of them. So those matrices are stored in the row major or column major. We don't know. So he is suggesting which one is better. He is asking you which one is better, so that the time complexity of an algorithm should be efficient. Anyone? Asif, do you have any idea? Those people who are watching, do you have any idea? Two matrices you want to multiply, right? So if those two matrices are stored in which format, so the time complexity will be efficient. So I will read once. Two matrices M1 and M2 are to be stored in arrays A and B respectively. Okay. Each array can be stored either in the row major or column major order in contiguous memory location. The time complexity of an algorithm to compute M1 and M2 will be, right, best if A is in the row major, B is in the column major, best if both are in row major, best if both are column major, independent of the storage system. So is there anyone who have idea on this? Anyone having any idea? Please let me know if anyone having any idea. Yeah, I will try this. So I will try this. This one I will try this. This is the A matrix. Suppose in that n elements are there. So sorry, suppose in that n rows, n column. So n square elements. This is the B matrix. It is also assumed that n square elements. So when you are multiplying, this row will multiply with this column. This row will multiply with this column. This row will multiply with this column. So it's keep on going, you know very well, you know very well. First row will multiply with all columns. First row, first column, first row, second column, first row, third column, and so on. Next one, second row, first column, second row, second column, second row, third column, and so on. Third row, first column, third row, second column, and so on. I think if you observe clearly, right, here all elements you are covering. Here also all elements you are covering. And if you cover all elements, how it matter row major or column major? How many elements you are covering? How many elements you are covering? Here also n square elements I am covering. Here also n square. So in my opinion, right, time complexity of multiplication of two matrices is completely based on, right? It's completely based on row major, no, column major, no, right? Independent of the storage. It doesn't matter how you store. You have to access all elements independent of the storage system. Right? It doesn't matter how you store, row major or column major, because all elements anyhow you have to access. All elements anyhow you have to access. Right? So to multiply two matrices, you have to access anyhow all elements. So answer is independent of the storage scheme. If anyone think some other thing, please let me know. If you think some other thing, please let me know. Yeah, can we go further? Independent of the storage scheme. Independent of the storage scheme. Answer for this problem is D. I think many people know. If anyone don't know, please remember it is a tricky problem. That is the reason I taken. He will tempt you by saying row major. He will tempt you by saying column major. He may tempt you many ways. Right? Fine. Perfect. Let's move to next. Let's move to next. Yeah, this problem. Problem number 155. Problem number 155. An element in an array X is called leader if it is greater than all the elements are present on the right hand side of it. The best algorithm to find all leaders in an array is. It's one of the nice problem. Can you check? An element in an array X is called leader if it is greater than all elements to the right of it in X. The best algorithm to find all leaders in an array is. Solves it in linear time using left to right pass of the array. Solves it linear time using the right to left pass of the array. Solves it using divide and conquer in time theta of n log n. Solves it in time theta of n square. Can you see this? What is the answer? Yeah, I will try this. I will try this. Is one of the nice problem. I will try. See this? First element, second element, third element, fourth element. These are the indexes. Fifth element, sixth one, seventh one, eighth one, ninth one, 10th one. 10 elements are there. 10 elements are there. Let me give some elements. 55, 80, 23, 66, 17, 31, 46, 55, 28, 28. Let me try. Let me try this. Maybe I think I can say 25. Some numbers. So as per the definition, see this one. As per the definition, what he is saying? This element is said to be a leader if it is greater than all elements present on the right side. A particular element is said to be a leader if it is greater than all people present on the right hand side. I think he is not leader because right hand side people, some people are greater. So he is not a leader. Right? If you go to the 80, 80 is a leader or not. He is greater than all people present on the right hand side. Check. Is he greater? Yes, I think he is a leader. What about 23? Is he a leader? Right? So he will be greater than all people on the right hand side? No. 66 is he leader? Is he greater than all people on the right hand side? Right? Yes, I think yes. 17? No. 31? No. 46? Is he greater than all people on the right hand side? Is he greater than all people on the right hand side? No. 55, yes. 28, yes. 25, yes. So the possible leaders are 1, 2, 3, sorry, 3, 4, 5. I am printing the leaders. 80 is a leader, 66 is a leader, 55 is a leader, 28 is a leader, 25 is a leader. There are 5 leaders. There are 5 leaders are there. In the given array, there are 5 leaders. Some people are asking, sir, what will be the time complexity for this? What will be the time complexity for this? Some students are asking. What will be the time complexity for this? Some students are asking. Remember, if you start this problem from the left hand side, this will be compared with all the people on the right hand side, n time. This also compared with all the people on the right hand side, n time, n time, n time. If you start from the left hand side, this problem will take order of n square. But if you take from right hand side, this problem will take n time only. Some people are asking, sir, how, sir? I will explain. This problem is going to be much easier if you start from left hand side. This problem is going to be much easier if you start from right hand side. Let me start from right hand side. So remember, right hand side, first person is anyhow leader. From right hand side, first person is anyhow leader, but you have to do one important task here. Just manage one variable max. Max is equal to initially 25. He will be the leader already. Now what you do is now compare with other people. Now see, new person is coming. Right? So this person will be compared with other people. So let me remove unnecessary people. So these are unnecessary. So this problem is going to be interesting if you start from left side. If you start from right side, it is difficult. Right? So first person itself is the leader from the right hand side. Okay. Now that will be compared with other people. So now people are asking, sir, how can I say 28 is a leader or not? Right? See this one. How can I say 28 is a leader or not? Very simple. Until now, maximum is 25. Until now, right hand side maximum is 25. Until now, right hand side maximum is 25. Right? Comparing that person, your element 28 is greater? Yes. Yes. Then he will be leader and you have to update also. So now 28 is a greater element. 28 is the greatest element until now on the right hand side. See, until now these people are over. In that greatest element is 28, which is there in the maximum. Now, some people, how to check 55 is a leader or not? You no need to check all the right people because right hand side greater people, right hand side greater person is 28 till now. Comparing that person is greater means I think 55 is a leader. So update this one, print it. Till now on the right hand side greatest element is 55, which is there in the maximum. Which is there in the maximum. Now, easy leader compare with the until now maximum. No. Easy leader compare now until now maximum. No. Easy leader comparing with until now maximum. No. Easy leader comparing with the right until now maximum 55. Comparing 55, 66 is bigger, is a leader. Whenever leader is updated, max also will update. Max also will update. Max will become 66. Right? Next one. Next one. Right? Until now, so let me adjust all the people. Let me adjust all the people. Until now, on the right hand side, greatest element is 66. Comparing that one, 23 is greater? No, he is not a leader. 80. Until now, greatest element is 66. Comparing 66, 80 greater? Yes, 80 will be a leader. Update it. Right? Next one. Until now, greatest element is 80. Comparing that 55 is greater? No, is not a leader. So what I mean to say, if you start from left hand, if you start from right hand side, just one scan like this. Whenever leader came, update the max. Whenever leader came, update the max. Do that. If you do that, this problem can be solved very easily. This problem can be solved very easily. Order of n time. Order of n time. Right? This will take order of n time. Right? Please careful. I hope everyone is fine. The answer for this problem is, let me go to the option, let me check. Solve it linear time using left to right pass of the array. Solve it linear time using right to left pass of the array. No. Solves it using divide and conquer in log n time. Divide and conquer n log n. Maybe, but better option is option A. Solves it in time theta of n square. That is also maybe, see, all may be correct, but better option is A. Right? It will solve this problem so easily if you do from left hand side. Sorry, if you do from right hand side. Yeah, fine. Let's go to this problem. Question number 69. Assume that the algorithm considered here sort the input sequence in ascending order. Okay. If the input is already in the ascending order, which one of the following is true? If the input is already in ascending order, which one of the following is true? To keep in ascending order, quicksort will take n square time, yes, true. Bubble sort will take n square time. Original bubble sort will take n square, that is true. But if you do small change in any pass, right, swaps are not there, stop it. With that condition, best case. With that condition, best case becomes order of n. Right? So when the best case will come like this, already sorted. If you do one pass, number of swaps became 0. Number of swaps became 0, stop it. Because the elements are already in the ascending order. If you do one pass, no swap will be there. You can stop it. Right? You can stop it. Right? I think he's saying n square, but n is the answer. Math sort is always n log n. It cannot be the answer. It is wrong. It is also wrong. Next one, insertion sort is order of n time. Yes, I think 1 and 4. D is the answer for this. Everyone know. Everyone know for this. Next one, minimum number of swaps required to build a mini heap tree for an array containing n elements is. So n elements array, you want to construct a build heap. Suppose assume that all elements are same, right? Whenever you are doing the build heap, no swap required. Right? All. So compare with the parent, no problem. 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 Right? Because of all are same, no need to swap also. I think answer is 0. It is a tricky problem, please take care. Answer for this one is 0. It's a very tricky problem, right? Please take care. Next one. An array of 125 distinct elements is to be stored using quicksort. Assume that the pivot element is chosen uniformly at random. 125 distinct elements are there. Is to be sorted using quicksort. Assume that a pivot element is chosen uniformly at random. The probability that the pivot element gets placed in the worst possible location in the first round of partitioning algorithm is the last place. I think 2 possibilities it can go to worst case. Out of 125 locations, 2 places. This is the probability. It's a very simple question. Next one. Yeah. That, right? So those people who are seriously writing gate examination, those people who are writing the gate examination seriously, right? EPT RIC course is really useful to you. Right? You can happily join because for every subject, 300 questions we are going to solve. 13 subjects, 300. So approximately 13 threes, right? I think 39, approximately 3,000 to 4,000 questions we are going to solve. If you solve all of them, you are going to get 70 plus marks. It will be really useful, right? You can join this. In the next class, we are going to discuss the remaining problems. Thank you so much. See you in the next class. Thank you. Thanks everyone. Thank you.